6.6 matching equations to their graphs. Remember to put a date on your notes and remember to put your name on it. Mine's Tara. So let's just jump into some examples here. Example 1. The three graphs below have these equations, but the graphs are not in order. Y equals 3x plus 3, x plus y equals 3, and y equals 3x minus 3. So to match each equation with a graph, pick some points and substitute. So the easy ones are to talk about your x and y intercept. Your x-intercept is where, I'm just going to label this here, x-intercept. Your x-intercept is where it intersects with the x-axis, and your y-intercept, I can just call that int. Your y-intercept is where it intersects with the y-axis. So you'll notice that there's a similarity for all x and y intercepts. This guy right here, the x-intercept here is 3, 0. The x-intercept here is going to be 1, 0. And this x-intercept here is negative 1, 0. So you're noticing that they are all different. However, there's one thing that is the same, and always the y values are 0. So if you ever want to find out what your x-intercept is, substitute y equals 0. What about our y-intercept? So this point is at 0, 3. This point right here, this is our x-intercept, even though it's not above the x-axis. This right here is our y-intercept. It's where it intersects with the y-axis. It is negative 3, 0. And this guy right here, our y-intercept is 0. Oh, sorry, I made a mistake here. This should actually be 0, negative 3. Do you see what I did? I wrote in for my y my x and my x my y. Sorry about that. See, everybody does it. So if you find yourself making that mistake, don't worry about it. Just be aware. And this one right here is 0, 3. So with our, let me just highlight a few things. With our x-intercepts, we always have the y-coordinate being 0. And for our for our x-intercept, y equals 0. For our y-intercept, our x always equals 0. So that is just, those are just two important kind of cues, because 0 is always easy to substitute in. Always, always, always. So if you want to pick a point and substitute, my suggestion is pick a point that is on one of these graphs, like say something like 0, 3, and let's see if it's on this first graph. So test 0, 3, and you kind of want to pick a point that is unique. This graph has 0, 3, but this graph does not have 0, 3 on the line. This one right here does have 0, 3, but we have a different x-intercept, so we can try a different one. So let's test 0, 3 and y equals 3x plus 3. So this is my x. So I'm going to substitute in my x equals 0, and let's see what our y equals. So 3 times 0 plus 3. Y equals 3. So on line, y equals 3x plus 3. It does have that point. So this graph could match up with this one. Let's test another point on this one. Let's test 3, 0. So when I substitute in my x, I should get a y of 0. So x equals 3 times 3 plus 3, y equals 9 plus 3, y equals 12. So since when I substitute in 3, I do not get 12. So what you can say is does not match. So the first graph is not y equals 3x plus 3. Now we have to use a little bit of logic here. So this one has the 0.03 and this one also has the 0.03. That means this one does not though. This has 0, -3. So that means that this graph right here is this one. Is the one that we tested in. Because there are only 2 graphs, either this first one or this one, that has the 0.0, 3. We know that graph A does not match with y equals 3x plus 3, so we can arrive at the conclusion that graph C is y equals 3x plus 3. So we don't need to test this point anymore, those points anymore. Let's test the second graph here. X plus y equals 3. X plus y equals 3. So let's test a few points. So we don't need to test anything on this graph anymore because we know that we've figured that one out. But let's test the point. Why don't we test the point 0, -3? So test 0, -3. So for my x, I'm going to substitute in 0. And if I substitute in 0 for my x, I should get -3 for my y. So I'm just going to copy this and substitute 0 in for my x. So 0 plus y equals 3. So this does not match. -3 and 3 do not match. So do not match. So x plus y equals 3 is not graph B. So by process of elimination, we know that x plus y equals 3 is this graph.